Okay, dear friends. Now, this paper is paper two. Of course, we will focus more on that because this is the first major paper. One is on 28th of April. I think that is the paper three for you people. And then this paper two. And then paper one is, of course, in June. And we will be having a lot of time after 20th of May or 22nd of May, something like that, to practice a lot for that paper. But I will be solving that paper also maybe next week. But this week, only this paper two we will continue. Okay, now paper two we are discussing right now. And you can see this paper is from October, November 2022. Paper 2, variant 1, October, November 2022. And let's start without any delay because there are two questions actually, they are comparatively tricky. Rest is okay. So we need to move a bit fast on this. And let's start, my dear friends, from question 1. Question 1, 2, 3, comparatively easier, but then 4, 5 are good questions. Actually, we need to think and we will be discussing a lot on them. So now, walaikum assalam, Munzir. So now, my dear friends, let's without any delay, the boxes in figure 1.1 contains terms on the left hand side and examples of these terms on the right hand side. Draw a line between each term on the left and correct example on the right. So see base quantity, base unit, derived quantity, derived unit. These are the things which we are very much familiar already. So now one by one, we will start discussing, and it is not that much difficult. It is quite easy, very simple thing, by the way. It's quite easy, and we will be doing it comparatively quickly because it is simply a recall memory. It is simply what? It is simply a recall memory. So my dear friends, see here, base quantity here. There are 7 base quantities and one of them is electric current. So just join this base quantity with electric current. Base unit. Mass is the base quantity and kilogram is the base unit for base quantity. Then derived quantity. Of course, force is a derived quantity and derived units, coulomb, which is the unit of charge, that is a uh, derived unit. Quickly, I will share with you the names of the base quantities. One is length, its unit is meter, SI unit. Then mass, its unit is kilogram. Then time, its unit is second. I'm talking about SI base quantities and SI base units. Then electric current, ampere, temperature, that is measured in Kelvin, amount of a substance, that is mole. There is one more, luminous intensity, which is candela, not with us in the syllabus. So these 6 were the base quantities along with their base SI base units, which I have mentioned. So that was quite simple for 2 marks. Now the next is a set of experiment measurements is described as precise but not accurate. Precise, not accurate state. What is meant by precise? Simply, whatever the measurements are taken, we will say the measurements are numerical values. So, measurements are close to each other. That is precise, are close to each other. Like in this, for this point of view, precise but not accurate. I am going to measure the value of acceleration due to gravity on Earth. That is 9.81 meters per second square. Now my values are precise. How? If they are 10.2, 10.25, 10.30. So now they are almost precise, but not accurate. Why they are precise? They are close to each other. Or I can say 10.20, 10.21, 10.23. They are very close to each other. So they are precise, but they are not accurate because they are not close to accurate value, which is 9.81. So this way we can define precise and accurate. And even you can say their range is very small. So even we can write they are with small range. That's why they are very close to each other. No, not accurate. So the average, let me say, average of the measured values or of the measurements, average of the measurements is not close to the true value, close to true value. Okay. Now see here, my dear friends. Very simple. Like I told you 10.21, 10.23, 10.20. So what will be their average? Their average will be almost 10.21. So that is not close to 9.81. I'm talking about for the value of acceleration due to gravity. So these are the definitions. Very simple. If this was accurate, so we can say then it was accurate instead of not accurate. Average of the measurement is close to the true value or nearly true value. So then that will be the answer. Wherever, my dear friends, you are having the doubt, please you can write in the chat box. You can raise your hand. You can ask me. I will come back to that question. Okay, but of course, as recording in progress, so I would like to go in a fast mode so that we can cover this paper quickly. We can solve this paper. An object of mass m travels with a speed v in a circle of radius r. The force acting on the object is given by F is equal to mv square over r. And in general, this force is the resultant force, or we call it centripetal force, which is always directed toward the center of the circle or the curved path. So anyhow, the percentage uncertainty of the three quantities are given in the table. For force, it is plus minus 3%. For mass, plus minus 4%, or plus minus 5%. The values of V is the value of V is determined from F, M, and R. Calculate the percentage uncertainty in V. Calculate what? The percentage uncertainty in V. So how to calculate that percentage uncertainty? First of all, V is not the subject of equation. We are supposed to make V as the subject of equation. So my dear friends, when I'm writing, so I can write cross multiplication that mv square is equal to fr. This implies that v square is equal to fr over m, and then taking the root on both sides, my dear friends, we are getting v is equal to fr over m and whole raised to the power 1 over 2. That's what, first of all, from the point of view of this equation. Now, power is 1 over 2. We need to calculate what? Percentage uncertainty. So my dear friends, percentage uncertainty in V, we can write 1 over 2. Power comes in the beginning, like last class also we did. Percentage in F plus percentage in M and percentage in R. Percentage in M plus percentage in R. So we are writing the values, my dear friends. So that is C 1 over 2. Then percentages in F is 3. Percentage in M, that is 4. And percentage in R, that is 5. So as we simplify them all together, and percentage I'm writing out, so it is 5 plus 4, 9 plus 3, 12. Then 12 divided by 2, simply it is equal to how much? 6%. How much is that? That is 6%. Simply, my dear sons, add them up together, but as the power is 1 over 2, so power will be multiplied with all of them. Anybody having any question at any moment, please feel free. You can ask me. Then the value of V is 15 meters per second. Calculate the absolute uncertainty in V. Method is only 1 mark. So absolute uncertainty, simply what to do? 6% of this. So absolute uncertainty, simply 6%. It means 6 over 100 times 15. And as we will simplify, my dear friends, the answer will be equal to 15, 6 are 90, and then okay, 0.90. And here also you can write plus minus, and here also you can write plus minus. So absolute uncertainty mean it can be added. Answer plus minus means what? Answer can be for the value of E 15.9 or 14.1. So answer is from 14.1 to 15.9. Got it? So this way, this is plus minus. That's why we are adding. So any question, any query at any moment, please feel free. You can ask me. Now come here. A steel ball is projected horizontally from the top of a table, as shown in the figure here. The ball is projected horizontally at a speed of this. So this is the horizontal velocity, which is staying constant because there is no resultant force acting on this side. The ball lands on the ground a horizontal distance of 180 centimeters from the edge of the table. From the edge of the table. Okay. And distance, this horizontal distance, this distance is also what? horizontal distance, that is 180 centimeter. Air resistance is negligible. Calculate the time taken for the ball to reach to the ground. Very simple. Speed is equal to distance over time. Now, simply time will be equal to distance along the horizontal over the speed along the horizontal. So, my dear friends, what can we write? So answer will be equal to, as we will be placing the values and we are getting the answer. So 180 you have to wake up here. It is in centimeters, so 10 raised to power minus 2. See, my dear friend, centimeter, and this one is meters per second. So 180 times 10 raised to power minus 2 to convert it from centimeters to meters over speed, that is 4.9. And as we simplify, my dear friends, answer comes to be 0.367, because I did it already so that we can not waste our time in a lot of calculations. So 0.367. So we can write into two significant figures. So answer can be written 0.37 and second is already given. So that was very simple, straightforward. But now calculate the vertical component of the velocity. Vertical component of the velocity. Now, my dear friends, vertical component of the velocity as it hits the ground. Now come here. If I'm going to do it, my dear friends, here, see when it hits the ground, let's suppose the ball is here. Okay, so when it will be hitting the ground, so the resultant will be almost, this will be the resultant velocity. My dear friends, they want us to calculate this one, which is along the vertical. And we know horizontal velocity stays constant. Alatul, before it was 4.9, now even it will be 4.9 meters per second. We need to calculate this vertical component of velocity. Now, what is the data which is given to us? My dear friends, the data which is given to us, that is, if you ask me, see when it will, when it started to fall down from this top table, here, initial velocity along the vertical, that was 0. Okay, so initial velocity along the vertical is 0. So I'm writing u is equal to 0. Then, my dear friends, acceleration due to gravity, acceleration will be equal to g, that is 9.81 meters per second square. Then time we have just calculated, that is 0.37 seconds. And what we need to calculate? Velocity along the vertical we need to calculate. So simply first equation of motion, because it is falling with constant acceleration. So v is equal to u plus at. U is 0, dear sons. A is equal to G, which is 9.81 times T, that is 0.37. So as we simplify it, we are getting our answer after rounding it off to be 3.6 meters per second. Now see, before we were already having 4.9 meters per second. So vertical component of velocity is now 3.6 meters per second. My dear sons, why to use this equation? This V is equal to U plus AT, or S is equal to V average times T, or S is equal to UT plus 1 over 2 AT square, or V square is equal to U square plus 2AS. All these equations can be applied only for the uniformly accelerated motion. In other words, when the acceleration is constant. And here, air resistance is ignored, as they told. So it means when it will be falling down, so the ball, steel ball will be falling down with the acceleration due to gravity. So we are right to use this equation. You may be thinking, sir, why you did not use the components or something like that? Because we are not given with the angle. So that's why here we are helpless to use that one. But we know it is falling with constant acceleration. So it means simply the acceleration due to gravity is constant. So we can use Suvad equations, and the equation according to data which fits to our data, that is V is equal to U plus AT, because nowhere there is distance given in this data for us. So it means we cannot use any of the Suvad equation which is including S. So only V is equal to U plus AT will be giving us the answer. Now, determine the magnitude and angle of to the horizontal of the velocity of the ball as it hits the ground. Now we need to calculate the magnitude. Now we need to calculate the magnitude of the velocity. And my dear friends, if I'm going to draw this diagram here again, see, this will be a right angle triangle. If we are going with head to tail rule, my dear friends, like This is 4.9 meters per second. Then falling down vertically, that we just calculated 3.6. So what will be the resultant? My dear sons, resultant will be by head to tail rule, mean from the starting point to the final point, that resultant velocity we need to calculate. And it will be making an angle theta to the horizontal here. That angle also we need to calculate. Now you can check. This is a Pythagoras theorem, mean right angle triangle. So sorry, Pythagoras theorem can be applied. So simply for velocity, my dear sons, we can write that v is equal to vx square plus vy square and root. And when I'm placing the values, I'm writing it equal to 4.9. That was the given horizontal velocity, and it stays constant, plus 3.6 square 4.9 square plus 3.6 square. As we simplify this, after rounding it off, we are getting 6.1. So here, 6.1 meters per second square. Now, angle, already horizontal and vertical component are given, and we need to calculate angle to the horizontal. So, my dear friends, very simple. Tangent theta is equal to opposite over adjacent. So, opposite is what? 3.6, and over adjacent is what? That is 4.9. This implies that when we are calculating theta, that is the tan inverse theta, that will be equal to tan inverse 3.6 over 4.9, and the answer comes to be 36 point something. So let's write it, two significant figures, 36 degrees. I think it is 36.3. So in this way, we can calculate the angle also. Muhammad Naji, Ahmad, Munzir, Muhammad Ashraf, Talha, Mahad, anybody having any question, please feel free. You can ask me. If it's okay, everything is fine.
Yeah.
Yes.
Okay, I can
Understood.
I can start asking you questions in between. Just wait now. Okay, first this question so that you can. This is just, let me say, brainstorming. I just want to make you wake up. Inshallah, tomorrow, all the definitions and all the important formulas for this. I am in the writing phase, typing phase. So inshallah, updated file you will receive tomorrow maximum. For all the equations, mean formulas, and also for the definitions. Inshallah, by maximum by tomorrow evening. So the ball is projected by means of a compressed spring, which is attached to a fixed block as shown in figure. And the ball is placed on the frictionless track in front of the spring. The ball is then pulled back so that the spring has compression of x naught. So when the ball is released, the ball is projected horizontally as shown in figure. You know, this is not actually, how did they projected this ball? Which ball? Here. So this ball was with, see here, it was attached to a spring, or it was linked with a spring like this way. You can see when the spring is pushed back, mean it was initially here, when then the spring is pushed back, means spring is compressed and released, so ball is thrown, and it is going with initial velocity of how much? 4.9 meters per second. Or he will move towards elastic potential energy, spring constant, Hooke's law, something like those stories. So that's why they gave the scenario. How did they projected the ball horizontally with the velocity of 4.9 meters per second? Now, my dear friends, here the variation with compression, x of the applied force F for the spring is shown. Now see, the graph is a straight line. You know, compression is also a type of extension. So see, this graph is force, instead of force extension, this is a force compression graph. Now two properties of the graph are there which are fulfilling for any two quantities to be proportional. So here force is directly proportional to the compression. Which force? You can say the restoring force here. So which law tells this force? Yes, Talha and Mahad, this graph is fulfilling which law? Can you name the, sorry? Yes, anybody? Mahad, I cannot hear you. Anybody? Which law is fulfilled here with?
Saying Hooke's law.
Yes, this is, my dear friends, Hooke's law is basically obeyed here. Why? the graph is a straight line. It is also passing through origin. So when these two properties are fulfilled, the quantities which are labeled on the axis, they are proportional to each other. So in this case, force is proportional to extension. That is Hooke's law. Okay, now if somewhere we need to calculate spring constant, so simply we can find the gradient of this graph, we can get the spring constant. But I don't know they are going to ask or not. What they are asking, oh, the ball is a uniform sphere of steel, diameter this, so diameter is this, so we need to get radius. So radius is equal to simply divided by 2, so 0.008, and it is in meters. Mass is given, and they want the density of the steel. They want what? The density of the steel. Now, my dear friends, density, we know that is equal to mass over volume. Mass is there, volume is not there. Let's calculate first volume. That is equal to volume, and this is a sphere. So volume of the sphere formula you must be remembering all the time, 4 by 3 pi r cube. So it means 4 by 3 pi and r 0.008, and don't forget to write the cube. So my dear friends, when we are trying to calculate this right now, okay, let me place the values in the same fashion here. So my dear friends, if I'm placing the values here, mass is 0.017, that is in kilogram. Good thing is all the quantities are in system international units. So here 4 by 3 pi r cube means 0.008 cube. And when I'm simplifying, my dear friends, I will be just writing, you have the calculators, you can check it out. So the answer after rounding off to two significant figures, it is coming to be 7,900 because it is steel. So density of the solids is more. So that is 7,900 kilogram per meter cube. It will not be exactly this, little bit change, but I'm using just the rounded off number and according to the mark scheme straightforward without wasting time. So you can check, you have calculators. My calculator is not here. It was with me when I was solving it. Just give me a moment. So I will be back in few seconds. Just give me a few seconds. Let me bring my calculator. So yes, my dear friends, when I'm solving this, three times 3.142 times 0.008 raised to the power 3. So my dear friends, this answer, for me, this answer comes to be 2.144 times 10 raised to the power of -6. Okay, let me place this in the formula then. That is 0.017. Sorry, 0.017, that is the mass over 2.144 times 10 raised to the power of -6. As I'm simplifying, my dear son, that is 7929. Actually, the answer is 7929. So we have rounded it off to 7,900, and here this is 2.144. Okay, so we are rounding it off to the nearest 100 or like this. So two significant figure is our preference in general. Now, all of the elastic potential energy, this is very important. Here you need to wake up everybody. All of the elastic potential energy in the spring is converted into kinetic energy of the ball. So it means no energy losses to the surroundings. So we can use the law of conservation of energy. That loss in elastic potential energy is equal to gain in kinetic energy. The speed of the ball as it leaves the spring is this. Show that the maximum elastic potential energy of the spring is this. Now we have speed, we have mass. So we will calculate basically kinetic energy, and that kinetic energy will be equal to what? Maximum elastic potential energy. I'm sure you are with me. So here we can just calculate the elastic potential energy, and we will be getting, my dear friends, what? We will be getting, so here, this one is important, that all of the potential energy is converted into kinetic energy. So no loss of energy. Okay. So my dear friend, I can say the elastic potential energy, or better, I should write it the other way around. Elastic potential energy, that is equal to change in kinetic energy. That is equal to what? Change in kinetic energy. As it is start, elastic potential energy graph is starting from 0. So change in potential energy, simply final potential energy minus initial. So initial is 0. So simply this will be EP. And here also, this will be simply KE final minus KE initial. Now, my dear friends, as the ball started from rest, it was held at rest with the spring, then spring is compressed. It is still at, when spring is compressed, the ball is at rest. So initial velocity is 0. So initial kinetic energy will also be equal to what? This will be equal to 0. So simply, what we can do, we can say that elastic potential energy maximum will be equal to 1 over 2 mv square. Mass of the steel ball is given up there, 0.017, and speed they just told, no, that is 4.9 and square. So when we are simplifying, my dear friends, answer is, of course, it should be equal to 0.20 joules. So that comes to be 0.20 joules. So that is the elastic potential energy. But here, my dear friends, mostly students will be thinking elastic potential energy is equal to area under the graph 1 by 2 kx square. So k is not with us, mean, or 1 over 2 fx. So what is the extension? Extension is not given. So just this first line is the clue that all of the elastic potential energy in the spring is converted into kinetic energy of the ball. So whatever is the kinetic energy of the ball when it is released from the spring, or it is leaving the spring and moving forward horizontally, so that kinetic energy is basically equal to elastic potential energy of the steel ball. Now, this is easy now. Use figure 2.4. See, there is a big hint to determine the spring constant K of the spring. As I told you in the beginning, K will be equal to F over X. No need to write delta F over delta X. The reason for that? Reason for that is very simple, my dear sons, that the graph is starting from 0. Graph is starting from what? From 0. So, see, this is, you can say, initial value is 0. So here, this is 10. So if I'm going to make the point, so this will be 10, and this is how much? 6. So small square 2 minus 0 over 10. So each small square is equal to 0.2. So my dear friends, this is 2 boxes above 6. So 6.4. Okay. So these are the points. So simply, force is 6.4, extension is 10. So I'm writing here simply 6.4 divided by 10. But here I'm doing a stupidity. What? See, the extension is in centimeters. Be very careful. So what to do? It is in Newton per meter. So 10 centimeter, how to convert into meters? Times 10 raised to power minus 2. And my dear friends, as you will simplify it, answer will be equal to 64. So value of K will be equal to 64 Newton per meter. But be very careful, not 10 as it is, because it is centimeters, and answer we need to give in what? Newton per meter. Now use your answer in B3 and the value of energy in given B2 to determine the compression of the spring. No, it's okay. Now we can use that compression equation, because hints are going on. The examiner is giving us the hints. We know elastic potential energy, that is equal to 1 by 2 k x square. So we can say now x naught square. We need to calculate x naught. Let's make x naught square as the subject of equation. So x naught square will be equal to 2 times elastic potential energy over K, and then, my dear friends, X naught will be equal to root and 2 times elastic potential energy was 0.20. Just we calculated, we have shown it. See this one over K. K we just calculated, that is 64. And as we are simplifying this value, and we are getting the answer 0.079, my dear friends. So what is the answer? 0.079 meters. Please, anybody having any query here, any question? Muhammad Naji, is that okay?
Yes, sir.
Okay, you know there is also one formula for elastic potential energy, simply area under the graph. And if we are going to calculate the area under the graph, this will be the area of the triangle. That will be 1 over 2 fx. But actually, examiner is kind enough. He said use your answer in B3. It means you need to use K. And B2 mean the energy. So 1 over 2 kx square, because 1 by 2 fx. So f is equal to kx. So kx times x, it will become 1 by 2 kx square. So that's why we are using this equation according to the given data. Now, oh my goodness, still this question, 17 marks question. Now, the steel ball is replaced by polystyrene ball of the same diameter. Diameter is same, but mass is lower. Okay, the spring is given in given compression x naught, so it means compression is also same, and then it is released. Air resistance on this ball is not negligible now. Before, the air resistance was negligible, now it's not negligible. So after it leaves the spring, explain why the ball leaves the spring with a greater speed than that of the steel ball. Why it is leaving now with a greater speed than that of the steel ball? My dear friends, I will write the answer, but I first want to explain you people. Like, EK is equal to 1 over 2 mv square. We have to talk about speed. So if I'm making, my dear friend, the speed as the subject of equation, I told you these questions, they are linked with any formula, sum of the equation that we used up there, so in any of the part above. So if I'm making v square as the subject of equation, or v square as the subject of equation, see, it will become 2 times ek over m. Now, my dear friends, you can get from here. See, extension is same, diameter same, so elastic potential energy will be same. See here, that is spring constant K, and x is same, so elastic potential energy same. If, my dear friends, loss in elastic potential energy same, then kinetic energy is also same. Please, I want attention from you people. Extension same, diameter same, only lower mass. So if extension is same, so it means elastic potential energy will be staying same. Spring constant is same, because elastic potential energy 1 over 2 kx naught square. So elastic potential energy same. We know the loss in elastic potential energy. The loss in elastic potential energy is basically the Ke. So it means Ke will be same. I'm not going in a lot of detail. I'm just writing the answer after this equation. I will explain this equation as kinetic energy is same. So when mass decreases, speed increases. How? See, speed is inversely proportional to mass. Mass is much lower when the mass is decreased. So speed will be what? Speed will be, dear sons, increased. It is 1 mark, but I gave you all. Even if it is for 2 marks, this explanation is more than enough for 2 marks even. So what is the scenario? Extension is same. Elastic potential energy, it depends on the extension within the limit of proportionality. So extension same, spring constant of course same, so it means elastic potential energy same. So loss in elastic potential energy is basically gain in kinetic energy. If the elastic potential energy is same, so gain in kinetic energy will also be same. So using the equation for kinetic energy, we are making speed as the subject of equation, and then v square is equal to 2 times ek over m. And now you can see, as kinetic energy is same, so it means speed is inversely proportional to mass. Even I have not converted v square. Let it be as it is, not a problem. So as the mass is decreased, so it means speed will be what? Increased. Now, why this ball takes a longer time to reach the ground than the steel ball? Now here, this answer will be because of air resistance. Now, my dear friends, for this one, air resistance will be increasing with speed. Is it falling with greater speed? So air resistance increases with greater speed. So resultant velocity will decrease. Sorry, resultant force will decrease. So it means acceleration will decrease. So it will take more time. Try to understand. See, initially when there was no air resistance, so force acting on this only was the weight. Now, and in the beginning, I'm writing in the start. So resultant force along the vertical was only weight. Now, in the new scenario, now what is there? Weight is constant. Weight is down, but my dear friends, there is small or more air resistance also. So now what will be the resultant force? Resultant force will be weight minus air resistance. Weight minus air resistance. So resultant force will decrease. And we know acceleration is proportional to what? Resultant force. When resultant force decreases, acceleration decreases. So of course, ball will take longer time. So I'm sure this will be clear to you people. Now just let me write in short words. I'm writing it. Even you can say vertical acceleration decreases. So our air resistance, or you can say resultant force decreases due to increase in air resistance. So it takes longer time because acceleration is less. Let me write in more. Okay, I will say that air resistance increases with speed. So, my dear friends, resultant force, that is equal to weight minus air resistance, decreases. So, vertical acceleration, or simply acceleration, you can say. So, vertical acceleration decreases and ball takes longer time to reach the ground. Then that you can write from the question, to reach ground, my dear sons. Please, any one of you having any query here? But this was 17 marks question. Now see, he put projectile motions, Seward equations, forces, Hooke's law even, and then also this elastic potential energy. A lot of topics he put in just one question. And I'm sure now this is already well, a lot of explanation there. I'm sure it will be not a problem for these two. One mark. No, even if they are coming for two marks, even then the explanation is more than enough. Please, anybody having any question here?
No.
Okay, let's move forward. Now define power. So simply, my dear friends, work done per unit. Done. No need to waste time. Now they are asking, calculate this, show this equation. Again and again we are doing. So mechanical power P can be written as the formula P is equal to FV. Use the concept of the work and definition of power to show this formula, how this formula is derived. Okay, how this formula is derived. For that purpose, my dear friends, simply you can write the equation of power, which is equal to work over time, and then you can write work is equal to force times distance over time. You can write here, since work is equal to force into distance. Now, my dear friends, power will be equal to force times distance over time. And what is distance over time? That is equal to speed. So simply power is equal to F times V. That's for 2 marks. No, we have done it many times. No need to waste a lot of time. The engine of a lorry provides 130 kilowatt of the power to the lorry when it is traveling at a constant speed of this. Okay, speed is given and constant speed. Along the straight horizontal road, show that the resistive force opposing the forward motion of the lorry is this. Okay, let's suppose this is the lorry. My dear friends, this is moving this way. So that will be the driving force. DF I'm writing. And of course, there will be resistive force. that will be in the backward direction. What do we need? We need the opposing force. If we can calculate the driving force, that will be resistive force. You know, resistive force is equal to driving force. Why? Why it is, Munzir, resistive force is equal to driving force? Can you tell me why?
Swedish constant.
Exactly, my dear friend. Very good. So power will be equal to FV. Just we did know this is the driving force. If we need this power is how much? 130,000 over V, that is 25. It is equal to F. And my dear sons, when we will say F, that will be equal to, simply on simplification, 5200 Newton, and that is equal to resistive force. So R is equal to F, that is equal to 5200 Newton. Only one mark, so no need to waste a lot of energy and time. It was simple. Let's move forward. This one. As usual, the lorry in the figure travels up a straight section of the road that is inclined at an angle of theta to the horizontal as shown in figure. Now the lorry has a mass m and acceleration of free fall is g. Determine an expression in terms of m, g and theta for the component of the weight of the lorry that is parallel to the. This you should be very now habitual, and you should be very clear to do it fast. Now see, if I'm going to calculate the weight of the lorry. So weight of the lorry is downward, my dear sons. And then there is a two components more. Okay, so one will be perpendicular to the surface. Okay, one component will be here and one will be here, which will be along this track. And you know, many times we discuss this, my dear friends, so you should be very quick enough. No need to think quickly. See, this is what? This is theta. So this is weight, that is equal to mg. So this one, now see, this one component which I have drawn upward, this one, this is opposite. So what it will be? This will be mg sine theta. This one will be mg cos theta. They want component that is parallel to the surface. So this one, which is parallel to the surface, this one. So what is that? Mg sine of theta. No need to, only one mark. Mg sine of theta. I can draw another diagram here for you people. Weight downward this way, then one component here and one here. Head to tail rule, you know. So this one opposite mg sine theta, this is mg cos theta, and this is the resultant, which is mg. So like this. Okay. Now the total resistive force remains still unchanged. How much? 200 Newton. And the engine now provide the greater power to maintain the speed of this. The total mass of the lorry is this. Angle is this. Determine the power in kilowatt now provided by the engine. No problem. Now the power provided by the engine. That's what we have to discuss, my dear friends. Now, as it is still moving with constant speed, it means acceleration is zero. It means resultant force is zero. Resultant force is what? Resultant force is zero. So now, my dear friends, resultant force is zero. Now see, on this one is the driving force. Of course, on this lorry, the driving force is this one. Let me say this is the driving force. Mg sine theta is already backward, and then resistive force is still same, that is also backward. Try to understand. So there are three forces. One is driving force forward, one is mg sine theta, that is backward also, component of the weight, as well as the resistive force, this is also backward. And this lorry is moving at constant speed. So my dear friend, the resultant force, it should be equal to zero because there is no acceleration. So what will be the resultant force? Dear sons, driving force minus resistive force minus mg sine theta, that is equal to zero. So first of all, let's calculate what is the driving force. Then we can easily calculate the power because speed is there. So driving force, my dear friends, I can write this driving force is equal to, on other side, minus will become plus, so 5,200 plus mass. Mass of this is 36,000, mass of the lorry, times G, which is 9.81, times sine what? 1.4 degrees. It is given here, 1.4 degree theta is mentioned here. Okay. So when we simplify, this driving force comes, my dear friends, I'm not going to round it off. It comes to be 13828 Newton. So driving force is this power in kilowatt. So no problem. Power is equal to force times speed. So dear sons, 13,828 Newton times V, which is 25. And as we are simplifying, answer comes to be 3,45711. So it means it can be written 3 to nearest 1000, 346, and then 000. And we have to write the answer in kilowatt. So you can write it 346. Maybe in the mark scheme it is written 350 to the nearest 10. Not a problem. So this will be the whole scenario. My dear son, the need is you need to understand what are the forces acting on this lorry. So the forces acting on this lorry, number one is the driving force, which is towards right. Of course, resistive force number two, which is towards left, and mg sine theta, this force, mg sine theta, third force, which is also towards left in the backward direction. As the lorry still moving with what? Still moving at constant speed, which is 25 meters per second. It means resultant force is zero, causing resultant force zero, which means the acceleration is zero. So what will be the resultant force? One force is forward, two forces are backward. We will subtract the backward direction forces. Then placing the values, simplifying, we are getting simply the driving force 13,828 Newton, then power is, I did not round it off the driving force, just multiply with V first, and then we are getting the answer 345,711 watt. We need to give the answer in kilowatt. So instead of writing 345,711, 346,000 and got it. Now see, as it is going along the up the slope, so more power the lorry engine has to generate so that it can go at the same speed. And see, what was the power in the beginning? Power in the beginning was it was given, it was 130 kilonewton. Now it is increased to 130 kilonewton. Now it is increased much more. It is now 346 kilonewton. So almost 3.5 times increase because it is going up the slope. So our answer is perfectly correct. Anybody having any doubt here, please feel free. You people can ask me quickly. Is that okay with everybody?
Yes.
Ahmed?
Yes. Yes.
Okay. Munzir, are you there?
Yes.
Talha, Mahad?
Yes,
Sleeping while awake?
yes, sir.
Okay. Let's move forward now. This is now question on physics of waves. Let's do it. First of all, simply the definitions. First of all, what is the meaning of polarization? Polarization means the oscillations are in one direction and perpendicular to the direction of propagation of energy. So I'm just writing to the point. So my dear friend, what is the answer? Oscillations are in a single direction. Oscillations, vibrations, whatever you want to say. Oscillations are in single axis, even we can say single. Okay, let me write axis, like x-axis, y, single axis, and perpendicular. Perpendicular, I'm writing this shortcut 90 degrees sine, no, perpendicular to the propagation of energy. Perpendicular to the propagation of, please, this lazim you have to say perpendicular to the propagation of energy or wave. Initial propagation of energy, the direction in which energy is transferred. Maybe this will, you will say, sir, what is this? And perpendicular. Okay, instead of writing perpendicular, and at 90 degree to the Direction of propagation. Now, why light waves can be plane polarized, but sound waves cannot? Light waves can be, only uh, transverse waves can be polarized. Did you get my point? Light waves can be polarized because they are transverse. Their vibrations are in all directions. But sound is already longitudinal. It is already in one direction. So light only, we can say only a transverse waves can be polarized. So one mark you can write only transverse waves can be polarized. Spellings, you can see yourself. Okay, now this question, let's start it. Two polarizing filters A and B are positioned so that their planes are parallel to each other. So their planes are parallel to each other and perpendicular to a central axis line XY, central axis line XY, as shown in figure 4.1. Then one is vertical transmission axis, other one is horizontal transmission axis. So here, unpolarized light, here the light will be in all poles. Here it is vertical filter, so only vertical light will be there, my dear sons. Only vertical light. Then here in general, see here, this is horizontal, so basically here nothing will come. Here I naught will become just zero because if you remember while studying, my dear friends, and I share with you some videos also from YouTube. See, this is vertical polarization. Only vertical can pass through it. But if this is horizontal, only horizontal can pass through it. If there is vertical, here is horizontal, so nothing can pass here. It will be completely darkness. If I'm throwing light, first vertical, some will pass. Then again, if there is horizontal, nothing will pass, and on the other side, there will be darkness. So that is the case here, but they are not asking this thing. They are asking something different. Now, the transmission axis of the filter A is vertical and filter B is horizontal. As I told you, unpolarized light of single frequency, which means monochromatic, is directed to the line XY, along the line XY from a source positioned at X. So source is at X. The light emerging from filter is vertically plane polarized. That's why I made like this and has intensity I naught. Okay, no problem. Now filter B is rotated from its starting position. Now filter B is no more like this. It is rotated. It is not exactly horizontal. It is rotated from its starting position about the line XY as shown in figure 4.1. After rotation, the intensity of light emerging from the filter B is 1 over 4 I naught. 25% is left. See, here it was I naught and here it is 1 over 4 I naught. Okay. Now calculate the angle of rotation of the filter theta from its starting position. Now, my dear friends, mostly these angles we are getting simply by what? We are getting these angles by Mollus law. So I'm going to use that Mollus law, but that is not going to give us the exactly same angle. We are not getting the exact angle here. I will tell you what to do. Now here, my dear friends, what is Mollus law? First of all, that is I is equal to I naught cos square theta, and this theta, my dear friends, theta is the angle between vertical and new position of B, filter B, new position of filter B. Okay, first of all, let's calculate this angle. Now, my dear friend, I is 1 over 4 I naught, and here it is as it is I naught, and then cos square theta. Then, my dear friends, I naught is cancelled with I naught. So what is left? We are having 1 over 4 is equal to cos square theta. Take the root on both sides. my dear friends, we will be getting cos theta is equal to 1 over 2. This implies that theta equal to cos inverse 1 over 2, and that is equal to 60 degrees. That is equal to how much? 60 degrees. Now, angle of rotation is not 60. Let's go back, my dear friends. Angle of rotation. Now, angle of rotation, you need to be very, very careful, my dear friends. This theta angle, which we have calculated, this is along the vertical. Okay, and let's suppose this is rotated. So, rotated this way, and now the new position of the filter B is this. Before it was here. Originally it was here. Now the new position is here. So the angle which we have calculated, this one is the theta. They don't want this. Examiner wants, already I have explained you this sort of one question. He wants this thing. Okay. So theta we have calculated. Now see, they are already what, perpendicular. So total angle is 90. One is horizontal, other one is vertical. So other total angle was how much? 90. So 90 minus this one. How much we calculate? 30. Sorry, this one we calculated, that is 60, my dear sons. This is how much we calculated, that is equal to 60. So what will be our this answer? So 90 minus 60, it will be equal to 30. That's what I'm going to do. So angle of rotation for filter B, that will be equal to 90 minus 60. That is simply 30 degrees, my dear friends. So be very careful. This angle which we have calculated, that was with the vertical. Now we have to calculate the angle between the new position and old position. If you want, I can draw this diagram roughly here. See, my dear friend, this was the filter B. This was the original direction, along the horizontal. Then, dear sons, this is the vertical. And let's suppose the new direction is here for the angle. They want this angle. Their answer is, we need to calculate this angle. And now we calculated theta by Moelu's law. That Moelu's law gives the angle between the vertical and the new position of B. They want the angle between the previous and the new position of this rotation. So this theta we calculate, that came to be 60. So see, this angle is total 90. So angle of rotation will be 90 minus 60. That's why we are going to calculate what? 30 degrees. We got answer 30 degree. Now, what is next? That is, I think, simple one. A microwave of intensity I naught and amplitude A naught meets another microwave of the same frequency and of intensity 1 over 4 I naught traveling in opposite direction. Both microwaves are vertically plane polarized and superposed where they meet. Now explain without calculation why these two waves cannot form stationary waves. My dear friends, just in the last paper we discussed one question where we said that for stationary waves they should have same frequency, they have same amplitude, moving in the opposite direction along the same line. Superpose or overlap to give rise to stationary wave. Here problem is amplitudes are not equal. You may be thinking, sir, why amplitudes are not equal? Initially intensity is I naught, then it has become 1 over I naught. And amplitude and intensity, there is a relationship that intensity is proportional to square of the amplitude. So if the intensity is decreased, it means amplitude is also decreased. So if the amplitudes are not equal, so how they can cause or how they can give rise to stationary waves? So my dear friends, here I'm going to write amplitudes are not same. If the intensities are not same, so amplitudes cannot be same. Amplitudes are not same, or you can say equal, are not same. So they cannot cancel each other at node. So at node, there should be amplitude 0. So one is more, one is less. When they will superpose, answer will not be 0. So they cannot cancel out each other at node on superposing. or when they superpose. On superposing. Okay. Better was to write when they superpose. Okay. Now, next again 3 marks. No, they won't. Determine in terms of A naught the maximum amplitude of the wave formed. The maximum amplitude of the wave formed. Maximum amplitude, it means for maximum amplitude, my dear sons, there should be what? There should be constructive interference. There should be what? Constructive interference. In other words, the amplitude should add up together. One amplitude we have, A naught we have, but what about the other amplitude? That we don't have. And as I told you here down, we know one relationship, dear sons. What is that relationship? We know that I is proportional to amplitude square. Amplitude square. So we can take the ratios of amplitude 1. We did it already in some questions where we were going to plot a graph. Amplitude intensity ratio of the intensities is equal to the ratio of the amplitudes, but they are squares. Okay. Then, my dear friends, let's place the values. I1, it was I0. I1 was I0. I2 was 1 over 4 I0. Here, amplitude was A0. This amplitude we don't know. Let it be AX. This we don't know. Let it be what? This amplitude which we don't know, let it be AX. And I'm making the whole square. Now, dear sons, I0 is cancelled with I0. What is left behind? Here it is 4. Because 1 over 1 over 4, very good mathematics as compared to me. So now it is A0 over AX square. I'm taking root on both sides. So my dear friends, we need AX. What is AX? So basically it will become A0 over AX equal to 2. We need the value of AX. My dear sons, AX will be equal to A0 over 2. Cross multiply. We need AX. Mean what will be the new amplitude? So new amplitude is half. Now, as I told you, they want maximum amplitude. So for maximum amplitude, we need to add the both amplitudes. So for maximum amplitude, we can say that these two values are equal. So my dear friends, maximum amplitude or resultant amplitude, I'm writing here. Resultant amplitude is equal to A0 plus A0 by 2. A0 plus A0 by 2. A0 plus A0 by 2. So this will be simply equal to 3 by 2 A0. A0 is written, either you can write 3 by 2 or you can write to 1.5. A0 is already written. So what to do, my dear friends? Here, very simple. This we did many times, in the plotting of graphs, we want maximum amplitude in terms of A0. So maximum amplitude means some sort of constructive interference. So that amplitude, they can simply sum of the individual amplitude will be the total amplitude, constructive interference. One amplitude we have A0, other we don't have. We can find it out. So we know that I intensity is proportional to square of amplitude, then the ratio of the intensity is equal to the ratio of the amplitudes. Okay, and then just simplifying, making AX unknown amplitude, that is equal to A naught by 2. For maximum, they should be added, and on addition, we are getting 1.5 A naught. Okay, my dear friends, now state Ohm's law. So that is simple statement. I'm sure you know very well. So let's write it quickly. So current in a conductor is proportional to potential difference across conductor, because 2 marks, so we need to write in detail. Cross conductor provided temperature remains constant. This is simply the statement, provided temperature remain constant. Today, my sons will stay with me for maximum 5 to 7 minutes extra. Now, the variation of current with potential difference V for a filament lamp, it is shown, and you can see as the potential difference is increasing, the current in the end is decreasing because temperature of the metallic conductor filament lamp will be increased. The resistance of the filament lamp increases with potential difference. State how the graph shows this. You can see the gradient of the graph decreases. Gradient, it was supposed to go this way, sorry. It was supposed to go this way, it is decreasing. So you can write only 1 mark, so you can say that gradient decreases. Explain why the temperature resistance rises this way. My dear friends, temperature of filament increases. So, when the only 1 mark, that is enough. Temperature increases, so the kinetic energy increases, average kinetic energy of the molecule, electrons and increases. So they collide more frequently, so resistance increases. So that's why just temperature of the filament increases, that is more than enough. Now come here. Here, my dear friends, figure 5.2 shows a circuit with a battery of electromotive force, EMF of 12 volt connected to a linear potentiometer AB and two identical filaments P and Q, filament lamps. So these are identical, their power same, their resistance same. So like this. The battery has a negligible internal resistance and the lamps each have the same IV, mean characteristic shown in figure. Characteristic for them is same. When the slider of the potentiometer is at the midpoint as shown in the figure, the current in the battery is 1.78. Current in the battery is what? 1.78. So current in the battery, my dear friends, we can think about like here 1.78 amperes. Determine the current in the lamp P. Current in the lamp P. So see, lamps are identical. So they are AB and P and Q are in parallel. So here it is 12 volt. Here total is also 12 volt as the lamps are identical. So 6 volt here and 6 volt here. So they want the current in the lamp P. So my dear friends, simply as shown in the figure, so 5.2, we can go now 6 volt. See, this is the 6 volt, this point. So this will be the current, C 0.5. So 1.5. So what it will be? According, if we are using this C 0.5, so each small scale is 0.05. So it means this current is 1.55 amperes. So my dear friends, we can write here simply the current is how much, just from the graph 1.55 ampere. Now the total power dissipated in the lamp P and Q. So power dissipated, power is equal to I into V. So current is how much? Current we just calculated 1.55 times V is how much? That is 6. So when I'm simplifying this, so I'm getting 9.3 watt. But this is only in one lamp. He wants for both lamps. For both Lamp's power will be equal to 2 times 9.3. So as we will simplify, answer will be 18.6 watt. Now he's saying this was simple, not a problem. The resistance of the potentiometer between its ends A and B. Here we want this resistance between the ends A and B. For that purpose, my dear, and it is at the midpoint. If it is at the midpoint, my dear friends, so we need to calculate resistance at A and B. Let me draw this diagram here. As the resistances here. Now, my dear friend, one resistor here at the midpoint, huh? So one here, one lamp is here, one lamp is here, like this, my dear sons. No, please, attentive Shoya here. See, this current is still 1.78 ampere. Now here we know current is how much? 1.55. And as this was, this was connected in the midpoint, so these resistance is directly proportional to length. These resistances will be equal. So easily we can calculate, my dear friends. Now see, what will be the current here? That current will be 1.78 minus 1.55. So this current will be 0.23 ampere. Now easily we can calculate, my dear sons, by this diagram. Easily we can calculate. Here current will also be 1.55 ampere. And these are in parallel. Potential difference is same, but current is splitted. So 1.78 is divided here and here. So here already we calculate 1.55. So what is remaining here? 1.78 minus 1.55, so 0.23. When this is done, easily, my dear friends, we can calculate the resistance. How? We know R is equal to V over I. So what is V total? V is equal to 12 and I, that is 0.23. So when we simplify, answer comes to be 52.2. So here, my dear friends, the resistance is 52.2 ohms. Now, the slider of the potentiometer in C is moved to end A. State and explain the effect on the brightness of the lamp P and Q. Again, let's draw the diagram. So battery positive, negative, positive, negative. Here current comes here, then here. This is lamp P, then this is the contact between them. Here is lamp Q, and my dear sons, like this. Okay, so here it is simple 12 volt. This is again 1.78, and this is lamp P and this is lamp Q. Now what happens actually? See, the slider of the potentiometer in C is moved to end A. So this one is here at end A, no more in the middle. So it means if it is end A, resistance is directly proportional to length. And see, this was A, this was B. Now, if it is end A, it means this resistance is vanished. This resistance is no more there. That's why I did not draw this resistance. Now, when the current reaches here, my dear friend, when the current reaches here, at this point, it can move this way, it can move this way. Current always takes easiest path. Always takes easiest path. So no current passing through it. So Current goes this way, this way, this way, this way, even this, but no current here. So what will happen? My dear friend, they said state the effect on the brightness of lamp P and Q. Lamp P, my dear friends, is not glowing because no current. No current through it, so not glowing. So no brightness. But what will happen now? See, all the current will pass through this. So all the current will be passing through it. Voltage is also 12 volt here. So more energy, sorry, more power delivered. So this lamp P glow brightly. It glow brightly because all the potential differences across it, because the potential difference across it is equal to how much? 12 volt. So even here you can write that across that potential difference is equal to what? 0 volt. So that you can think about with the help of these diagrams, you can check. And if there is any problem, rewatch the video. Otherwise, next class you can consult me again. But just give me a few moments. Let's move now to the last question, which is very easy, by the way. Very easy from nuclear physics, this question. They are asking, what is meant by the fundamental particle? Means simply cannot be further divided. Very basic definition, cannot be further divided. Now, a lambda particle, we did not study it, but they told us the name, no problem, is a hadron and consists of an up quark, a down quark, and a strange quark. Show that. Now, show that the charge on lambda is 0. So we must memorize and remember these numerical values. So what to do, my dear friends? We know this is up quark plus down quark plus strain quark. He's saying answer should be equal to 0. Up is plus 2 over 3. Down is minus 1 over 3. And S is also minus 1 over 3. So E of the elementary charge. So this implies that 2 over 3E minus 2 over 3E. So answer is equal to what? 0. So that's for 2 marks. Very simple, not a big issue. Now, this is simply again a recall memory. Again, the lambda particle is unstable. It can decay into neutron and a pion as shown in figure. So lambda is decaying into neutron and a pion. So the pion particle consists of an up quark and an up anti-quark. So compare the properties of up and anti-quark. You know, properties, my dear friend, they have the same mass, but they are anti-particle. You know, anti-particle is having opposite charge, but same mass. And another property, equal and opposite charge, like electron and positron. Equal and opposite charge, my dear friends. Then next is why a neutron is classed as a baryon and pion particle is classed as a meson. You know, neutron, what are the baryons, by the way, which are having 3 quarks? And you can see here, neutron is having 2 down and 1 up quark. Whereas baryons, sorry, mesons, they are having only 1 quark and 1 its anti-quark. So my dear friends, neutron, this is simple memorization and you must be remembering their charges and these properties very close to the exam, very good. But neutron is baryon as it consists of 3 quarks. Whenever there are 3 quarks, it means baryon. While pion has 1 quark and 1 antiquark. Antiquark, okay? 1 quark and 1 antiquark. So remember it that baryons, they are having like protons, neutron, they are all what? They are all baryons. So QUA, QUA or K. So whereas meson, they have 1 quark and 1 antiquark, and that's what. And this is in this way the end of your exam. Only few questions were tricky, rest was okay. So now next class again paper 2, and I will solve, otherwise my wish. You can do one thing, you can share with me any particular paper, sir, we want to solve this paper till Wednesday evening. So then Thursday, same paper I will solve. Otherwise, I will sort out a paper and I will solve that question paper, inshallah. So my dear friends, stay blessed, all of you. In case of any question, any queries, you can send me your questions, and you can also contact me through WhatsApp group, even over this group. Stay blessed and safe. Have a nice day, and assalamu alaikum.
Alaikum salam.
Right.
Excellent.